Okay, so Jagannath, thank you for taking the time to talk to me today, and also, of course, to the students at the University of Waterloo. We're going to be talking about Industry 4.0, or what's also known as the Industrial Internet of Things. But before we start, I'd just like to ask you to tell the students about yourself, who you are, and what your job is now.
Sure, Peter. And I'm assuming, Peter, you're recording this so that you don't lose it.
Yes, I am.
Okay. So, yeah, my name is Jagannath Rao. I basically hail from India. I have a undergrad degree in electrical engineering, and I have a graduate degree in what is called knowledge engineering. It's just another fancy word for artificial intelligence. And I work for Siemens. I've been with Siemens now for almost 33 years. I've been in different locations, different capacities, started in Siemens India, spent a few years in Siemens Germany, spent 14 years in Siemens in Singapore, and the last 10 years in the US. So I've done different roles and different jobs, but the last 5 years of my career has been more focused on software, more towards industrial software, industrial systems, and in the recent times also into PLM systems and the Industrial Internet of Things platforms. That's what I do today, and that's been my journey.
Thank you. That gives the students some
and if I
context.
may add, yeah, and if I may add, Peter, I forgot to mention, I'm not new to the university life. I'm also a professor, part-time professor at the University of Georgia here in Athens, and I run a course on machine learning and data analytics there.
Wonderful. That's very helpful too, and should help you in communicating with the students.
I hope so. I missed the whiteboard though.
Absolutely. It's we often talk with our hands and with a pen, but so for the discussion today, can we start by just explaining to the people who might be less familiar with it, and perhaps to those who do know a little bit, what you understand Industry 4.0 or the Industrial Internet of Things to be? How is that defined today?
Sure, and I think that's a great place to start because these are often either misinterpreted or misunderstood terms. Let me start off by saying that Industry 4.0 is not exactly the same as the Industrial Internet of Things. Yeah. IoT, or the Internet of Things, which got extended to Industrial Internet of Things for everything that is applied in manufacturing space, etc., is a term that got coined in the United States. Whereas Industry 4.0 is a term that got coined in Europe, largely originating from Germany. It was the German government which was behind this initiative, and my company Siemens has played a big role in giving inputs to that. But the big difference between Industry 4.0 and IIoT is IIoT looks at everything that is on a production floor in real time operating, connecting to those systems, gathering data from that system, analyzing those systems to make them more optimized in their operation or less downtime, or finding ways to get better yield from assets, etc. That's what IIoT in a traditional sense focuses upon. And of course, everything associated with data going into the cloud and doing analytics in the cloud, applying machine learning and all those algorithms on that. Whereas Industry 4.0 takes a more broader view of things. It deals with what we would like to call cyber physical systems. And if I may explain that a little bit, cyber physical system deals with everything that is starting from product design and development to production and the manufacturing systems, and then also everything to optimization of that whole production system in producing those products. And in addition to that, when these products and systems are operating in the real world, you connect them to IIoT systems so that you can now start getting data of performance and operational things. So you can see the big difference. It's a much broader view of things. And cyber physical systems basically, or Industry 4.0 for that matter, basically it assumes or it expects, Peter, that the products and systems to be manufactured, that all the information necessary to do that is contained within the process of producing that product. So for example, if you design the product, these are designed in modern CAD systems with simulated software to test them. So you can actually, it's very interesting, you can actually design and develop a complete product, test it for all its functionality without building a single prototype in real life. And you can do this iteratively till you've got your best product design completely simulated for all its features and functionalities. And that is exactly what we call a digital twin of a product. And that's what I mean by all the information is contained within it.
Wonderful and fascinating. So you're starting to talk about the technologies that are used. What do you see as the main technologies that are used in Industry 4.0 or which are likely to be used in the near future?
Right. So we've reached a point of time in this world with manufacturing production where you'll have to break it down into a virtual world and a real world. So technologies that are used in the virtual world, and when I talk about virtual world, it's just exactly what I described now, the digital twin concept. So technologies that are used in virtual world are a high-end CAD system, simulation software systems where you can do really complete simulations, not just for functionality, but also the physics of it. So if you have a motor, you simulate in every aspect, including the motor actually functioning supposedly in an environment. So CAD, high-end CAD systems, simulation software systems, and then what we call PLM systems, which is basically like a backbone of data management. We have Siemens has a product called Team Center, which forms that data management system, because you're now developing all these things and you're gathering digital data, and you need to be able to exchange that data across the board, right from design to later into manufacturing. So you have that as. So in the virtual world, those are some of the technologies that are used. Now, when you convert this into a real manufacturing line and a product is produced, then we talk about things like automation systems, robotics. We talk about advanced machine tooling systems, CNC systems. We talk about networked systems, where all systems in a plant sit on a network, which allows us to communicate the data. And of course, then what we have started calling now connected systems, which allow us to connect to the industrial Internet of Things. And then that leading to more technologies like cloud computing, edge computing and analytics, and of course, the use of machine learning and deep learning and all those technologies. So you can see it's a broad plethora.
Very interesting. And Siemens's technology integrates all of these various technologies to enable organizations to use the data that comes from it. Is that correct?
That is correct. I mean, at the cost of bragging a little bit, we are perhaps the only company which is able to integrate it end to end.
Thank you. And potentially very valuable. So my next question is, what is the impact that organizations are hoping that Industry 4.0 will have on their performance? How is this going to impact their activities, especially their operations and supply chain, but potentially probably in other areas too?
Right, and they are tremendous, and it's interesting. I mean, all these evolutions come from how the marketplace has changed and how the customer's demand has changed, right? So we are all, I mean, just to give you a simple example, we are all used now to every 6 months having a new smartphone. It's become a kind of expectation, especially among the younger generation, to have the next version of a phone. So what that basically means is product go-to-market life cycle times have dramatically reduced. That basically means that innovation life cycle times have to dramatically reduce. It also means that businesses have a very short window for a given product to make profit, because then it goes out of vogue. So the expectations, therefore, are how can I shorten time to market? Therefore, how do I reduce my innovation cycle? And everything that I described in terms of digital twin simulating helps us to do those kinds of things. The other aspects that is expected is there's a demand in the marketplace for mass customization. People might want the same model of an Audi, but they want it tweaked in different ways for them. And so you want to have the flexibility in manufacturing where on the same production line, you're able to do these customized individual pieces, and that's becoming more and more important. So that's the other expectation. The third one I would also say is that there is a huge pressure on resources like energy. There is a huge pressure in terms of competition and differentiation. And so you want to be ahead of the market. You want to be operating at the lowest operating cost. All those pressures also, the expectation is that Industry 4.0 will address all those. So from productivity to optimization to flexibility in manufacturing to reducing operating costs, those are really some of the things that people expect Industry 4.0 to solve for them, And I'm pretty sure these technologies will evolve further. If I look at it a little bit in the future, also having things like remote operations with technologies like augmented reality and virtual reality, you will be able to work with experts around the world because that's the other commodity which is scarce, expertise. We are losing a lot of the expertise with the baby boomer generation, which I belong to. I don't know if you still belong to that, Peter.
But on the cusp, yeah.
But so those are all the things in the future that we will start seeing those technologies take over. Before we reach a stage of which I'll talk separately to some other questions of yours, saving some for the next ones. But we'll end up with something that's called autonomous manufacturing.
Okay, and that's a good description of what they hope to get from it. To what extent has it been implemented today? At what stage might you say we're at in the maturity of Industry 4.0?
Yeah, so it's a very mixed picture. So I think a lot of companies, at least a lot of the advanced companies, have done a lot of implementation in the context of what they do with product development, design, and manufacturing automation. I think companies are now also evolving, and this is in its infancy about connected technologies, IoT, and going that whole mile, and then going into technologies like augmented reality. So those are still in its infancy. So I would say that across it's a very mixed picture, but I would also say that give it 5 years time, and because the adoption of these things are so quick at the moment that you will see an exponential curve and a ramp up which will, I think, make it a much more mature situation in 5 years time. And it's not just these technologies, Peter. I mean, all the systems along the value chain have to adopt to that, supply chain being one of the major ones which have to adapt and adopt those technologies,
And as it does mature, as we see more adoption of these technologies, what might the societal impact of this be? How are people going to be impacted more broadly by Industry 4.0?
So, and that is a great question, and that's a big debate today, right? Because the very natural assumption is, we are getting all these things. Two things are going to happen: automation and robotics, and all this is going to take over our jobs, and we will be jobless. Or the other fear is, hey, I come from a technological world where I'm not used to all this. So will I have a job tomorrow? Do I have the skills to do this? I think those are the. And I think what will happen is the biggest impact on society is going to be, there will be a generation. There's always one generation when these technological changes happen, which will be affected. Some people will adapt, some won't, and there is going to be an impact, and we have to be honest about that. But I think on the other side, I don't believe that these technologies take away jobs. If you look at statistics, Peter, over the last 100 years, every time there has been a step change or a disruption in technological systems in manufacturing, jobs have grown and have not gone down. So of course there are other implications which we have to address as a society. How do we reskill people so that they can adapt to this? How can we train people to get used to some of the new technologies? How do we change our education systems? How do we provide a safety net for those who will never be able to make that jump? And I think those are debates and processes that are ongoing. But overall, I think it's going to be a positive impact on society because it revolutionizes everything. It improves your quality of life. It improves things like even healthcare, which are all subject to these technologies, and how healthcare is deployed. I think the number of jobs will grow. And we already see developing countries which are adopting these technologies, their living standards going up. So overall, I think it'll be a positive impact. There is always this negative undertone because of the misunderstanding people have on what these technologies do.
So you envisage that we'll go through a period of transition, but that the benefits are likely to outweigh the negative consequences that might arise from this technology.
Absolutely.
Okay, so where should an organization start in its implementation of Industry 4.0? What should their first steps be?
So, and that's a question a lot of my customers ask all the time when we go into discussions. And I would say it depends on where you are in your business cycle and in your cycle. I would say that if you are right at the beginning, then you have to look at this as, I first got to get my product development technologies completely updated so that I can have the most advanced technologies there. Once I have that, I focus on my manufacturing systems, and maybe I can do it in parallelly, but how can I bring my manufacturing systems to the level of automation and technologies that is required for us to develop smart products and use data in the manner where it helps us to implement the whole Industry 4.0 standards. And then what do I need to do to connect to the Internet of Things? So if you are in the early stage, look at production systems, get that done. Look at manufacturing systems, get that done. If you already have a sophisticated system in manufacturing and production, start thinking about, okay, how do I connect all these to an IoT platform, so now I can start looking at performance management and looking at optimization management, yield management. How can I close the loop and bring performance data back system so that I can now start tweaking design because I simulated something, I expected certain results, I now have real-time information on performance. Is it doing what I expected, or what can I do to change design? So depending on where you are, I would say you start looking at the next stages of implementation of these technologies. The ultimate goal is going to be that you have all these three stages: the product development, the production, and the actual real-time operation happening in a seamless manner, transition-wise and data flow-wise, and that you're able to close the loop so that you have a closed-loop system where your product and system are continuously evolving with real-time data.
And what will the challenges be that organizations will face in doing this?
So, well, one of the biggest challenges is many organizations that I've seen, try to implement all these things at the same time. Don't do that. Start small. Start in one area. Get used to it. Do it. See that it's yielding you results in that area. And now you have more experience. You learn from this, and then you can ramp up into other areas. So the challenges that really organizations face is to really build a roadmap such that they can do this in a manageable and not in a very overwhelming way. The other challenges organizations face in doing that, they need skilled people. They need different kinds of expertise. So these resources are not always available, and they're not also cost effective. They're expensive resources. So how do you manage the resource planning? How do you train people you already have to take them to the next level? Do you mix some fresh blood who have expertise with existing people? So those are other challenges. So HR, recruitment, getting the right skills, managing people. The other thing I would say is a lot of the younger generation I mean, you and I know this. They are looking for jobs which are cool, where they can do some of the most advanced things. How do we keep them engaged, and how do we bring them into the workforce, giving them what they expect in terms of the coolness around all these things? Things are going to be challenges that organizations will face, and they all hit you at the same time. So you really have to deal with it,
But I don't know if it's just me, but I think it's tremendously exciting what's happening with technology and industry today. And I can't think why the people watching this wouldn't want very much to go and work in it. I think the careers that are going to be possible with the changes and the new technologies they're going to be working with are very exciting. But that might just be me.
No, you're right.
Sorry,
you're right. No, I think you are absolutely right. It is fascinating. But then there's one step that we have to do as seniors, if I may say. We need to make sure that they understand the coolness of these technologies, that the education systems are exposing them to that. I can tell you, I mean, you've been teaching for many years, but I've been doing this for the last 4 years at the University of Georgia. And it's sometimes very surprising to me when I take a class which is filled with mechanical engineering students and electrical engineering students and computer systems engineering students. Sometimes the gap between what they know and what they learn and what's really happening in the industry is so big that my class has become a very popular one because I'm exposing them to all these technologies at the moment. So we owe them that, to get them to understand what this is.
Yeah, I think the same thing. That's for me the main purpose of the interview, is that it helps to make that connection between what they're doing now and the real world, both today and of what we know of what might happen in the future.
Exactly.
So the next question I've got is to continue on the theme of employees. You've talked a little bit about this already and explained your feelings about it. I don't know if there's any more you want to say about how organizations should manage the impact that Industry 4.0 will have on employees.
Well, like you said, I spoke a lot about it. A couple of things that I would add. I can say what we are doing as a company, for example. We are very, very proactively exposing all our employees. We are a large company. We have about 360,000 employees around the world, and they're all in different skill levels, different age groups. And so we are trying to give every one of them an opportunity to be able to attend courses, to attend practical training, to develop skills. We even sponsor them to go and get an education qualification while they are working, if that helps them to get to that next level. Everything that we can do to really make them compatible and allows them to adopt and adapt to what we call digital transformation. We are trying to enable them to do, So I think that's a very important step, really.
Yes, absolutely. I completely agree. Making the change as painless as possible and enabling them to learn the skills that will enable them to contribute as effectively as possible to the new systems that we're going to be introducing. So the next question is related to this, but is focused on managers. And for them, there will also be changes. Can you talk about how the role of managers in industry might change, what types of skills and knowledge they might need in the future that they have not really used so much in the past, perhaps?
Yeah, sure. And what is very obvious is if you're going to lead a bunch of people who are either going to be exposed to these technologies or already are savvy with these technologies, you already have a clear view that you have to do things differently than you did in the past, right? And some of those things are that I call it, you have to go through what is called into a transformational leadership style. You start now really looking at even yourself as part of a team, the manager, the leader as a part of a team. Learning has to happen with exchanges in the team, so environments that have to be more informal, more, encouraging things like try it out, fail fast kind of situations have to be encouraged and allowed. The leadership style of managers and their roles have to change to bringing up. I mean, I always say a team of people is like 5 fingers. None of them are of the same length, and they're all different, and some weaker than the other. But your job there is also going to be, how can you make sure that across the board you can bring it up so that the performance of the team overall is as expected, so that you build a culture of performance. But to do that, you have the role of bringing people together, allowing them to fail fast, allowing them to learn, to innovate, and giving them all the equal opportunity to build up their skills. That is very different from what perhaps you and I grew up with, where there was a manager and there was subordinates, and you gave instructions and commands, or you set down tasks and you set the guidelines, and they followed it. I think that is changing dramatically.
Yes, and I love your analogy of the team and the hand and the fingers. Not one I've heard, and that seems very effective. What is the impact of the way that operations are organized on Industry 4.0? Are there differences between traditional and lean approaches to Industry 4.0? Would it be implemented in different ways within different manufacturing approaches or systems?
In very, very different ways. And I give talks, and I have a slightly controversial view on this, so I will talk about it. The fundamental difference, Peter, comes from the fact that with all these systems, there's one common denominator, that is data and data flow. A lot of this is based on having data across the board. When I say across the board, I mean across the value chain. So it is not just product development, it's not just production systems, it is the complete supply chain. And I would go into the supply chain right up to the tier 2 and tier 3 supply chain, because a lot of what you're going to be doing in product development is on data that is coming from their systems and their supplies to you, and how they operate, and what you do is going to be impacted by how they operate. So they have to be all integrated, first of all, and data and data flow is going to be the common denominator. Now, having said that, if you go back and look at every time you have a problem in manufacturing and production, our approach in general has been throw it on lean and find a solution, right? And that's become a common way of looking at things. And I think that will change. The reason is because fundamentally lean and those kinds of approaches, they look at continuous improvement to start with. Yeah, they are not going to be doing step changes for you. Secondly, they follow material flow largely. A lean process, when you start looking at it in detail and how it is done, it largely follows material flow. Whereas what is happening today, and what is very important for manufacturing and production system, you have to follow information flow. Yeah, and therefore I think while lean has its place, it will continue doing those continuous improvements. But I think a focus on information flow and new methodologies, if I may say so, coming out of following information flow, will become the basis for achieving those step changes that we're looking for.
So how we use the new sources of information and new technologies that allow us to work with information is going to be the more of the focus, which is not really incorporated in lean. That's basically what you're saying there?
Exactly. And let me give you an example, and maybe the analogy will help a little bit here for your students. So, if you have, let's say you want to optimize a system, and the lean team that has been put in place has this objective of optimizing a certain production system or process, etc. And they get all the material flow. They look at things like time and motion studies, everything that you do in lean, and you come up with certain tweaks at the end of it. And this could be a 1, 2, 3, 4 months process before you come up with results, right? And you might come up with some results which when you deploy, you find some incremental change or improvement. Contrast this with, I've got all my systems connected, every piece of my production, development of product, supply chain, I'm able to gather all the data. They're completely self-sufficient in terms of data generation. And now I subject this to a technology like big data analytics, using all the fantastic machine learning, deep learning algorithms that we use. And all this happens in the cloud and happens in a day, in 2 days. Once you collect the data, it happens very, very quickly, and you get an insight. You get an insight into, so this is where the bottleneck is, for example, could be one of the insights. And then you make a dramatic change once you've understood that. Happens in very short time, happens in a very different way, and happens in a manner where implementing those changes becomes fast and easy. So that gives you a sense of why they are so different, following information flow and following material process and time flow,
Okay, thank you. That I think it makes sense, and we can think about that further. How do you see Industry 4.0 changing business ecosystems, the networks that organizations exist within? Will that change significantly because of Industry 4.0?
It will more than significantly. It is already changing. Even a company always believed we had all the know-how and the resources to develop technology, change the world, so to speak. Even we have come to realize that it's unless we participate or develop an ecosystem, it's not going to be possible to harness all the richness these technologies provide you. And the simple reason why that is so is there is no company out there today which has all the domain knowledge and expertise to answer all the problems or give solutions to all the situations that are present in the manufacturing world. And so you have to be able to work with partners. These are what I call open systems, and not in terms of open source or free, but more in interoperability, in terms of working with partners, building common solutions. This is becoming the more and more the norm, and this is the way things will go. So it's going to be a very collaborative, very partner-driven environment, because there is no customer there who's going to allow you to say, all right, you come into my plant. Yeah, I know that you can do only so much, so you solve this part of the problem. I'll try to find somebody else to solve the other part of the problem. No customer is willing to accept that situation. Customers say, hey, if you come in, you address my plant. And I can, as part of an ecosystem.
Thank you. And the environmental impact of Industry 4.0, have you thought about that at all, or is there going to be an impact, positive or negative, on the environment?
Well, there should be. I mean, the expectation is there should be a positive impact. I mean, Siemens has really embraced these technologies and implemented it not only for customers but in all our manufacturing facilities, which are far larger in number than many of our biggest customers. And it's all based on the concept of sustainability. You want to be green, you want to be a neutral energy consumer to the extent you can. You want to be applying these technologies to produce less waste, to produce less pollution. You want the system to be also cost effective, in many ways. So whichever way you look at it from a sustainability perspective, the expectation is it is going to improve all that, And I'll give you an example of which we haven't talked about: additive manufacturing, 3D printing and manufacturing. Just imagine, I mean, if you go back to the old ways, which was basically taking a piece, just as an example, taking a piece of metal and removing stuff from it and using what was left over. This is exactly the reverse process in additive manufacturing, where you just keep adding layers and layers and layers, and then you have a finished product. That itself dramatically changes what wastage could look like,
Great example. I just have one more question, and it is, whether you have any final words of advice for the students who may be watching this as they're thinking about their future careers and preparing for the world with Industry 4.0, is there advice that you'd like to give them?
Sure. I mean, we all love to give advice, don't we? So, what I tell my students, one of the things is, make yourself aware of these technologies. There is enough information out there. Even if you don't have a course in a university which specifically deals with machine learning or specifically deals with autonomous manufacturing, there are free online courses. There is material. Keep yourself always updated. And secondly, when you're in the university environment, you have the luxury of engaging with these technologies, do projects where you can use some of these technologies and find ways to incorporate into what you do in the universities. The third thing I would also say is these technologies, Peter, are changing so fast on a day-to-day basis. You better be, as a student or as an employee or as a senior or somebody who even just retired, all of us better be in a continuous learning mode. Otherwise, we will be, I gave a commencement talk at UGA last year, and I gave an example there, which I thought would be interesting here too. Most youngsters are used to using smartphones, right? If you look at smartphones of the youngsters, they have all these kinds of apps, which is amazing. But they also know that, if they have an app on a phone, which has not been used for a while because, they downloaded it thinking it might be useful, but never used it because it never had any value. After a while, you delete it. So I keep telling them, don't become like that app. Somebody will delete you. Don't make yourself irrelevant. That's a big, that would be my advice. You use the best things going on there.
Good advice. Thank you for talking to me. I know that this video will be valuable to the students. I think we've talked and introduced Industry 4.0 to them, and I really appreciate you doing this for us, Jagannath. It's going to be valuable for the students.
Oh, absolutely. And I know, like I said, teaching these students, I've realized how valuable sharing industry experience is, and I'm happy to do that. And anytime you want me to visit you and talk and do something, I'm happy to do that for you.
I would love that. That would be a great thing.